All right, so we're going to get the derivative of this function. So this function is a squared binomial. So how would you get the derivative for this case? So there are two ways. You can expand this one before you differentiate, or you can apply chain rule of differentiation. Okay, so let's go to the first method, which is expansion before differentiation. All right. So in terms of expansion, you can either do these things. You can either first do for method, or the second way, you're going to follow an algebraic technique. Okay? So for my case here in tutoring you guys to answer this problem, I'm going to use the second technique. Okay? So the technique here in expanding a squared binomial is simple. So it only involves three steps. The first step is you're going to square the first term. Okay? Then, next step, 2 times first term times the second term. Okay? Or to put it in a English way, basically, you're going to multiply 2 by the product of the first term and the second term. All right? Then lastly, you're going to square the second term. Okay, so that's it. All right, so let's apply it here. First is you're going to square the first term. So the first term here is your 2x. So you're going to have the square of 2x. Wait, hold on. Let me fix this. Oh, square of 2x. That's it. Now we're going to proceed to the second step. So the second step here is 2 times the first term times the second term. So this is 2 times the first term, which is your 2x, times the second term, which is negative 1. That's it. Then lastly, you're going to square the second term, which is squaring negative 1. Okay, that's it. All right, so I recommend using this technique because if you keep squaring a binomial and then you use this method all the time, I can guarantee that you can expand a squared binomial easily and quickly if you're going to practice using this method. Okay, so all right, so I'm just going to erase this one because I'm going to occupy this space for solution. Okay, so now that we already apply this technique, so we're just going to simplify them. Okay, so here, the square of 2x will give you 4x squared. Then for this one, the second term, just multiply them thoroughly. So 2 times 2x, 4x, times negative 1 will give you exactly negative 4x. And lastly, for the third term, which is the square of negative 1, will give you positive 1. Because the square of negative 1 is basically, the answer for that is positive square of 1. Square of, what do you call this one? Basically, what I'm trying to point out is, if you're going to square a negative number, the result would be positive square of that number. All right? So for example, if I have negative 2 square. So what is the square of 2? Right? The square of 2 is 4. Okay? And as you can see, right, we have negative sign. So if you're going to square a negative number, the result would be just positive of that square of number. So hence, the square of negative 2 will give you positive 4. So same thing here, the square of negative 1 will give you positive the square of 1, which is 1. Okay? Okay, guys? Basically, if you're going to square negative number, the result would be positive. All right? So yeah, that's it. Okay. So we can now differentiate this one because this function is already expanded. Okay. So let's observe the terms given. So first we have 4x squared. So in this first term, we have a coefficient or constant of 4. Then we have x squared. Okay? So basically, we have a variable that has an exponent of 2. So what are we going to do with that? So as you can see, we're going to use this rule in terms of having a variable that has an exponent. So you're going to use this, what we call as the power rule of differentiation. So in this case, okay, if you encountered a term that has a variable in which it also has an exponent, then you're going to use this rule. Okay, just simply bring down the exponent, copy the variable, and then the exponent you brought down will be subtracted by 1. Okay, so you're going to use this rule for this case. Okay, well, how about this one, negative 4x? So for negative 4x, you can use this technique also because overall, the x here, right, is just a simple and decent x. But it also has an exponent of 1, right? So you can use this technique. There is no problem with that, okay? But for convenience, you can use this instead, okay? The derivative of cx, okay? Basically, when we say the derivative of cx, that means you're getting the derivative of a constant times the x. All right, and the x here, the exponent is 1, okay, which is the same as this one. So getting the derivative of a constant times the variable or the derivative of cx will give you the result of c. Okay, so that's it. Then lastly, we have a constant term. So what would be the derivative of a constant term? So this one is just simple. Okay, if ever you encounter any constant term, the answer for that would be just z. Okay, so that's it. So let's now apply these rules to this one. Okay, so we have 4x squared. So first we have a coefficient of 4, right? So we are not going to touch this one. We're just going to leave it for a moment. Basically, don't touch 4 yet. Okay, leave it be for a moment. Now, you're going to get the derivative of x squared. Okay, you're going to get the derivative of x squared. So, you're going to use this power rule. Okay, because this x has an exponent of 2. So, what to do, guys? Just copy this formula. Okay, or you can just do it mentally. Okay, if you know the essence of this formula. So just simply bring down the exponent, copy the variable, and then the exponent above that you used to bring down will be subtracted by 1. Okay, then next, here we have the second term, which is negative 4x. So as you can see, this one is very simple, all right, because the x here is just simple x, all right. The exponent here is simply 1, right? The exponent of x here is simply 1. So you can either use this one, power rule, or just simply use this technique, all right, for your convenience. okay, and to avoid complication and confusion. So for me, I'm going to use this method, okay, because the derivative of cx is equal to c. Hence, the derivative of negative 4x is equal to negative 4. See, much more convenient than using the power rule. Okay. Then lastly, the derivative of the constant term, which is 1, will just basically give you the result of 0. So we can now simplify. 4 times 2 is simply 8. Then copy the variable. Then here we have 2 minus 1. So 2 minus 1 is obviously 1. So 8x raised to 1, or just simple x, because it's just the same. Okay. Next, we have negative 4 plus 0 will just give you negative 4. So yeah, that's it. This could be your final answer. All right. But if you want to find a simplified answer, you're going to factor out this expression by 4, because the GCF of this expression is 4, because these terms, 8x and negative 4, are both divisible by 4. Hence, we're going to have 4 times quantity 2x minus 1. So this is your final answer. All right. So this is the first method. Basically, you're going to expand before you differentiate. Okay. So yeah, that's it. Now let's proceed to the second term. Okay, let me erase the writing. So the second term is we're going to apply what we call as the chain rule. Okay. So when we say chain rule, basically you're going to use this method to differentiate a composite function. So for example, we have f of x, right? And then we have g of x. So if we have f of g of x, then that means this is already a composite function. So basically, this g of x is the input of f of x. Hence, we have f of g of x. Okay. So how do we differentiate, okay, or get the derivative of f of g of x? Wait, hold on. My handwriting is not good. Forgive me. Okay. So how are we going to get the derivative of f of g of x? All right. So the answer for that one is basically, okay, f prime of g of x times g prime of x. So what does this mean? This basically the apostrophe sign. Okay. So this apostrophe sign is the same as the notation of derivative. Okay. So, right, the derivative of y is just the same as y prime, or is just the same as f prime. Okay. So when we see this one, right, this one, oh sorry, this one and this one, basically the apostrophe sign, it means that's the derivative of that function. Okay. So let's go back. Okay. So what does this mean? Okay, it means you're going to get the derivative of the outer part, then get the derivative of the inner part. In other words. So again, let me simply take it slow. All right. Hold on. So basically, get the derivative of the outer part, okay, which is you have f prime of g of x. Okay. Then next, get the derivative of the inner part, okay, inside. So you're going to get the derivative of g of x, so which is g prime of x. Then after that, multiply them together, okay? So that is what we're going to do in this case, okay? So yeah, all right. So first, let's take a look. We have a square of 2x minus 1. So as you can see, the outer part here is basically parentheses, right? And then we have an exponent of 2. Okay, that's the outer part. So what are we going to do? Okay, we're going to get the derivative of the outer part first. So the outer part here is the parentheses and the exponent of 2. So what is the rule of differentiation I'm going to use? I am going to use what we call as the power rule of differentiation. Okay, power rule of differentiation. All right. So just simply, okay, bring down the exponent, which is 2. Then copy the inside stuff here, which is 2x minus 1. Oh, hold on. Let me fix that. 2x minus 1. Then the exponent above you used to bring down will be subtracted by 1. Okay? Fine. We are now going to get the derivative of the inner part. Okay? The inner part. So the inner part here is 2x minus 1. So what is the derivative of 2x minus 1? So for the 2x, you can either use this or you can use this method, which is the derivative of cx, which is equal to c. Okay. Then for negative 1, okay, so for this one, we're going to get the derivative of the constant term, which is equal to 0. Okay. So let's get the derivative of the inside function. So what is the derivative of 2x? This is what? This is the rule you're going to apply to this one. So the derivative of 2x is just 2. Okay, according to this rule. All right. Then what is a derivative of negative 1? So the derivative of negative 1 is just simply 0. That's it. So we can now simplify. So we're going to have 2 times quantity 2x minus 1, okay, raised to 1, or just simply leave it be, okay, then times 2 plus 0 is just simple as 2. So we're going to combine 2 and 2 by multiplying them together. So we're going to have 4 times 2x minus 1. And that is your final answer. See? It's actually quicker than you expected. Because this one is the simplest technique of using chain rule. There's like another technique of using that one, but it involves substitution of letters, like U substitution. All right. But for convenience, we're going to use the simplest technique because the overall process of getting the derivative of a composite function is basically getting the derivative of the outer part, then get the derivative of the inner part. Just like this one, as you can see, the outer part here is that we have an exponent of 2, right? That's the outer part. So we can imagine that the inner part is just your x. Just imagine that. Then apply power rule. So you have this one as a result. Okay, you have this one as a result. Then after that, next you get the derivative of the inner part. So the derivative of inner part is 2x minus 1, right? So which is will give you 2 plus 0. That is a derivative of 2x minus 1. Okay, then simplify them and combine them together, you have 4 times 2x minus 1. So that is your final answer. All right. Don't worry, in the future I'm going to upload a video about using chain rule in simplest way as possible. All right.